with Scott, a podcast devoted to listening to the personal stories of living economists and helping build an oral history of the last 50 years of the profession. I'm Scott Cunningham, the host, a professor of economics at Baylor University. And today I'm excited to introduce to you Ashesh Rambachan, an assistant professor of economics at MIT. Ashesh's research spans causal inference, which for those of you that are longtime listeners know that I have a special interest in bringing on guests that make contributions to that area. His research spans that area of causal inference, but it also includes work that you don't usually associate with causal inference, which is machine learning predictive algorithms. So a lot of you are probably familiar with Ashesh's work on difference and differences with John Roth in their paper recently published in the Review of Economic Studies, A More Credible Approach to Parallel Trends. But I bet many of you that are very interested in and know about that paper may not know about his work on algorithmic fairness. Sorry, I'm getting all garbled here. So that's what we're going to do a lot of our talking about today. So I want to turn it over to them. I'm not going to take up much more of your time, but thanks so much for tuning in. And I hope you enjoyed this interview as much as I did. Okay, well, it is a pleasure to have with me on the show a person I've actually not had a chance to talk to before. I think maybe we've emailed maybe before, but we've never really spoken before. For the sake of the listener, can you introduce yourself? Tell us your name, your full title, and who pays your bills?
Yeah, so my name's Ashesh Rambachan, and I'm an assistant professor in the economics department at MIT.
Yeah, that's awesome. All right, well, great. Well, thanks for being on the show, Ashesh. Let me start with an icebreaker. What's a vacation that you have taken in your life before? It's not your favorite. It doesn't have to be your favorite. It doesn't have to be your least favorite, but you've noticed that it's popped into your mind every now and then.
Oh, that's a fun question. I guess yeah, it's a vacation I think about often was so I grew up in Minnesota. So every time the summer rolls around, my family would always do like a weekend trip to the Wisconsin Dells, which
Oh,
is indoor water park city for those who know the Midwest. And so for whatever reason, whenever the summer rolls around, I'm always thinking about when am I going the family trip to the Wisconsin Dells, which is it's a very oddly magical place. So would highly recommend if you're in Wisconsin.
are you going to do it this summer?
No, so this is why I think it's just nostalgia for my childhood because I haven't actually gone back since like high school.
Oh, okay.
But it's a lot of fond memories, and
Oh,
it's a genuinely an absurd place. Why there are like 10 different water parks in the middle of rural Wisconsin.
that's crazy. And they're like top water
Yeah.
parks.
Oh, it's amazing.
Oh, wow. Okay. That's awesome. So, yeah, that's great. Well, okay. Well, so tell me, where did you grow up? You said you grew up in Minnesota.
Yeah, that's right. Yep,
Where
grew
in
up.
Minnesota was it?
So I grew up in a suburb of Minneapolis, called Apple Valley.
Hmm. Okay.
Yeah.
Okay. How big is Apple Valley?
It's about like 40 or to 50,000 people or so. It's like 30 or 40 minutes outside of the Twin Cities, Minneapolis, St. Paul. So not like quite a small town, but not like a super big suburb.
Okay. Okay. What'd your parents do for a living?
So my mom, well, I guess she's now retired, was a family physician. And then my dad, he was actually also a professor, but he was a professor in a religion department at a sort of small liberal arts college in Minnesota.
Oh,
So
wow.
so he did research in and then taught sort of broadly about sort of South Asian Indian religions,
Oh,
but really focused on Hinduism.
oh, interesting. What kind of stuff was his research topics about? Was it stuff you could explain?
Yeah, so kind of broadly at so he's done a lot of work on like interreligious like dialogue, so trying to
Mm,
compare sort of like interacting with folks of different religions, thinking about what are sort of common themes across religions. Then a little more recently, there's like a strand within Christianity called like liberation theology, which
Yeah.
I think about how Christianity can be used to argue for, progressive ideas. And so he's been
Oh.
thinking of what does that look like in Hinduism as well?
Oh, there might be a version of that in Hinduism.
Yeah.
Oh, does it? Okay. All right. That's cool. So do you have any siblings?
Yeah, I have two older siblings, one older brother and an older sister.
Oh, okay. So they were all, it was all three of you guys going to the water park in the
Yeah.
summer. They weren't so much older that they didn't go.
No, so my sister, she's 8 years older than me, so there's quite a big age difference between us,
Yeah.
and my brother 4 years. But as I was saying, the Wisconsin Dells, has fun for people of all sizes, so they would all come along too.
What's the scariest ride at the water park there in the Dells that you've ever been on or seen, or that might even be too scary?
There was one when I was a kid that I was really scared of. It was like this. Have you ever seen like those like drop
Yeah.
slides where you just kind of stand on a platform and then it just opens up underneath you and you
My
shoot down?
gosh.
There's a couple of those, and I was always terrified of it.
Yeah, that sounds terrible. Okay. So what about what about when you were back in Apple Valley? Like what could I have found you doing on a Saturday when you were like middle school?
So in middle school, on a Saturday, I was probably just hanging around at home. So I did played like up until the end of middle school, I played a lot of like random little league like sports. I did like soccer, a lot of baseball. And then uh starting like sort of the end of middle school, there's like uh there's like a version of it in middle school, and then there's like a big activity in high school, like around speech. So I was like on the middle school speech team, and there'd be these like little competitions on like Saturday mornings. So kind of, yeah, mostly probably splitting my time between
Mm,
that random little league sports and then I don't know, just hanging around in my neighborhood.
yeah. Oh, that's cool. Okay. And so when you were like in middle school, did you have anything that you ever said to yourself, this is what I want to be when I grow up?
Yeah, I guess I'd probably I think I'd always sort of thought about doing something in academia is the wrong word, but I guess since I am very close to my parents, in particular my dad, and so I'd always just sort of seen him as a professor. So I think I'd always sort of thought of that as an option.
Mm-hmm.
Uh, but it was kind of either that or default into, some version of like doctor, lawyer, engineer,
Mm-hmm.
vague mess.
Yeah.
But I don't think when I was young, I really had like this is 100% the profession wanted to do.
Yeah, 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 right, right. That kind of vague professionalism of like, although having that professor as a dad, that probably added something that a lot of your friends didn't necessarily have, even that
Oh,
idea.
absolutely. Yeah,
Yeah,
absolutely. I mean, I think because of him, I knew like, oh, there's actually a career you could have
yeah,
sort of being an academic, doing research, whatever that actually is. It is something that people actually do in the world, which
right.
if he was not, if I didn't have that in my life, I don't really know how I would have gotten exposed to it until I went to like college.
Yeah, 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 sure, sure. So you go to Apple Valley's high school. How big is that high school?
Yeah, so there are two high schools in Apple Valley, the Apple Valley High School and then Eastview High School. So I went to Eastview High School. And that was like maybe like 2,000 students total, like
Hmm.
about 500 or so in a year.
Yeah,
So yeah, not crazy large, but definitely like a pretty decent sized high school.
yeah, yeah. Large enough where you walk down the hall and you're like, I've never seen some of these people before in my entire life. How is that possible? We're here every day.
That's right. We're here every day, and we somehow all live in like a 3 square mile radius.
And you're a complete stranger. How have I never laid eyes on you before? Yeah, right. So what kind of classes were you I mean, I know you probably, well, was everything pretty much wired for you? You had to take these classes, or did you have a lot of discretion over what you chose?
No, it's pretty set. You show up your first year and then there's a pretty clear set of everyone takes like an honor, like a government class, everyone takes like an English class.
Hmm.
The sort of main and science or the science classes are pretty standardized as well. Sort of
Hmm.
main differentiation in my high school was you could either opt into like an honors math track or
Hmm.
like a regular math track, which in retrospect are like horrible names for like telling kids like you're either a regular kid or not.
Right.
Uh, and so then if you took like the honors math track in big air quotes, you would start with, I guess it was like algebra 2, which I have still have no idea what the numbers associated with algebra mean. And if you
Right.
were in the regular math track, you would start with like algebra or something like that.
Yeah. Yeah. So which one were you in? You were in
Uh,
the honors
yeah, so
group?
I started with algebra 2. And so
Uh-huh.
then that meant if you were in that track, you could take like AP calculus by the time you
Mhm.
graduate.
Could you see that coming all the way in middle school that you were like, yeah, I'm pretty good at mathematics? That was something you always sort of had a feel for?
Is something I always enjoyed it. I mean, hilariously, I was not in the honors track in middle school. Basically, there's the way the district worked was you had to, if I remember correctly, you had to take some standardized test at the end of like fourth grade,
Yeah.
and that determined whether you got placed into the honors track in fifth grade, and then that was the track you were in through middle school.
Uh-huh.
And then there was like another standardized exam at the end of middle school that would determine where you went, plus some
Mhm.
teacher discretion where you went in high school.
Yeah.
And I was, let's say, not a very good student at like sitting quietly for for
Uh-huh.
tests.
Yeah.
So I remember I did really badly on whatever test determined the regular versus honors classes going into middle school.
Yeah.
And mom was not happy with me about it.
Yeah. Yeah. But you still, but it's funny though, your dad, he goes into this religion track and you're sort of and you felt this real connection with him, but like you're clearly kind of being drawn into this more STEMish sort
Yeah.
of. You've got these STEM talents. Was anybody in your family surprised to that that would be the case? That I mean, that you would have this career kind of as a someone who's very technical?
Um, yeah, I don't know if anyone, I guess since my mom was a doctor, I like
Yeah.
she did a lot of like STEM work in college and then went to
Right.
medical school.
Yeah.
Um, and so like I think she was a very big like driver in the sense that like math and science is important,
Yeah.
and valued that. And
Mhm.
then my dad was just more than anything else, like wanted us to be like intellectually curious people.
Mm.
Uh, and so I think the combination of those two, I guess, is what pushed probably all three of me and my siblings into like really caring about, schoolwork.
Right.
Um, and then I think probably the math and science part comes a lot from like my mom.
Uh-huh. Sure. Yeah, yeah, yeah. Right. When you said doctor, I for some reason got captivated by your dad's religion focus. Well, so when you were graduating high school, when you were about to graduate, what if I could have like eavesdropped on your teachers like in the faculty lounge, and just said, and they were talking about you, what to the outside, to your teachers, what do you think they saw about you that was like, what do you think they would have said about the kind of kid you were and where you were going?
So I think so certainly by the end of high school, I really was very excited about kind of anything in, for lack of a better word, like the space of public policy. So I
Huh.
did a lot of sort of the main activity I did in high school was like debate, and then a
Mm,
particular type of speech called like extemp speaking,
Mm.
where you would get like you would be given some question about like current events and then have like 30 minutes to come up with your answer and then present it for like
Oh,
6 or 7 minutes.
yeah.
And I really loved it, and loved like just the chance to think about current events and like
Mm.
policy problems. Who knows what I said, if anything is actually reasonable.
Yeah.
Uh, but so coming out, so that as because of that experience coming out of high school, I like really knew I was interested in that space. So I think a lot of my that was very clear to my teachers as well.
Yeah.
Uh, and so I think if you heard that, I think they would have forecast I would continue in that direction.
Yeah.
I think given like what my high school was like he had like an AP Econ class, which was really great, but there wasn't much exposure to the fact that you can take ideas from like science and math and use them to think rigorously about sort of policy questions that kind of
Mm.
me when I was an undergrad.
Mm.
So I think my teachers would be sort of unsurprised that I ended up in economics, but maybe surprised like what that work in economics actually looks
Right.
like.
Right. Right. Oh, that's interesting. So speech and debate, I was almost conflating them. This wasn't debate. This was you were giving public speaking.
Yeah, that's right.
And you
That's
were
right.
speaking about, and it would be like you would randomly draw a policy question like climate change, and you'd have 30 minutes to prep.
Yeah, yeah. So you would the way you would work is you would be allowed to like bring with you before we like had laptops in our speech and debate team, you would be allowed to bring these like plastic filing tubs where you could
Oh,
print newspaper articles, cut them up, and then like organize them by topic.
yeah.
And so you would like draw a question. I don't know, like this was what, like 2010, 2011. So something about monetary policy, who knows?
Right.
And then go to your little tub, you have like a folder, like,
Yeah.
here's all the New York Times articles
Yeah.
talking
Yeah.
about
Yeah.
that recently.
Right. 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 Was it a
It'd be
lot of
hilarious.
economics? Was it a lot of, I mean, if it's public policy, it is going to get into a lot of econ.
Yeah, so there's a good amount of like economics questions, and then a lot of like internet questions about like international affairs.
Oh,
So
huh.
yeah, like I was in high school. I think like one of the big topics was like the Arab Spring had started in like 2011. So there's a lot of
Mm.
questions about like, what's going to happen in Egypt, what's going to happen in Tunisia, things of that, not
Yeah.
exactly that, but things of that form. And so you
Right.
like foreign affairs articles, then you'd have like a 16-year-old
Yeah.
going in from some, mom from Minnesota to start
Yeah.
opining about the future of democracy in the Middle East. It's
Right. Right.
kind of an absurd premise, but it was very eye-opening to just get the chance to like learn about a ton of stuff that you wouldn't actually like encounter in at least in the high school classes that I had.
Yeah. 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 Sure. Were you, was your interest in public policy even there before you started the speech class, the speech club, or what is it? How would you describe this class? It's a class?
It was like an it's like an
Yeah,
extracurricular
yeah.
activity that you would like. So, most days after school, go like meet with my team, read,
Mm,
talk with them about these sorts of topics. And yeah, I think that's right. I guess it was a combination of things. Like one, I had always like an interest in definitely like the international affairs aspect of it. Both my parents were like immigrants to the US, but they were originally from Trinidad and Tobago in the Caribbean, lived in the UK for a while, then immigrated to the US. So like
mm,
they were always very paid attention to the news in the US, but particularly paid attention to like global news more generally.
uh-huh.
Uh, and so I think like from them, I was always sort of exposed to this is something important.
Mm,
Uh, and then also like I really love sports, but I wasn't very good at anything. So
uh-huh.
by the time high school came around, there's no way I was actually going to be on a on a
Right,
team.
right, right,
I
right.
kind of needed some extracurricular activity to not
Yeah,
drive my insane.
right, 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 right. So when you were graduating high school, do you now have a little bit more of, has your like what you want to be when you grow up, is it starting to take a little bit more shape than it had like 5 years earlier?
Yeah, yeah. So I think if you like, yeah, I think if you put truth serum in high school graduating me, I think I thought I would have wanted to like go work somewhere in Washington, D.C., whether that was like at a think tank or
Mm-hmm.
as like an aide in some like department of the federal government. Uh,
Mm-hmm.
and so when I started college, I I think I was, if I remember correctly, I was somewhere between like majoring in economics or majoring in like political science or
Yeah.
politics. That's the department at Princeton.
Yeah. Yeah. So you're definitely wanting a major though. When you're graduating high school, you're thinking of a major that will allow you to continue being more focused on public policy.
Yeah.
Right, right. So you're good. Am I right? You're clearly good at mathematics, but you're thinking about policy as a more of a form, more of how you want to spend your time at Princeton.
Yeah, that's right. So I'd say like yeah, in high school I like really loved all the math classes I took, did like AP Calc. I was like I was part of there was like a first trial run where they taught like multivariate they had like the opportunity to like take multivariable calculus as a senior. So I like took that, really liked it. But it was always to me just like before I started taking econ classes in colleges, I was just sort of, oh, math is fun. I don't really know how it intersects with these sort of other bigger picture policy questions that I was interested in. It's kind of
Mm.
just more like an intellectual curiosity on the side.
So how quickly do you have to declare a major when you end up at Princeton? Is it like immediately you start thinking of econ?
I think you had to officially declare at the end of your sophomore year.
Okay.
And so then in like your first year, there's like some general education classes that everyone has to take, but
Hmm.
they're pretty flexible. And so when I got there, I was like, well, if I'm choosing between economics or political science, I did AP Econ in high school, so it's like, okay, well maybe I'll skip the intro econ class. Let me take like the intermediate micro and macro classes.
Hmm.
Uh, and so I did that during my freshman year, and like those two classes together were like super, very eye-opening experiences because actually using, the language of calculus to talk about how people make choices and think about like economic growth. Um, so it was really the first, those two classes together were the first time that I saw, oh, these like two seemingly very distinct interests
Yep.
really intersected in a potentially very like useful and impactful way.
Do you remember who taught those two intermediate classes? Was it a professor or a TA?
Yeah, so the micro class was taught by Marco Battaglini, who
Uh-huh.
I think he's now at Cornell. And then the macro class was taught by Greg Kaplan.
Oh, okay. Okay. So do you take any econometrics while what is your reaction when you get into the econometrics class?
Yeah, so I did those in my first year, and then in my second year, I did the so I guess in so then I started taking um I never really done stats before. So I remember I took like this intro stats class in my freshman year it's like in the operations research department. So it's
Hmm.
like probability and stats, intro class for engineers. And I remember that was the class where I legitimately failed the midterm.
Oh yeah.
I got like 30 out of 100 on the midterm. That was like the first time in my life I had ever actually like failed an exam. Uh, but the professor was amazing. He's this guy named Sebastian Bubek, who's now gone on to like do really he used to do a ton of stuff on like bandit algorithms and now is like the LLM guy at Microsoft Research. So it's like
Oh, wow.
is kind of like he's like an amazing trajectory. But he taught me intro stats. And so I took that and like eventually recovered in the class. And like again, really that was again a case where it's like, oh, this is kind of like fun math, balls and urns, probability. I don't really quite
Yeah.
see where it's useful.
Mm,
And then I took in my sophomore year, like the intermediate econometrics class.
mm,
That was, you know, taught like out of the Stock and Watson textbook, and that was very. It felt a very similar experience as like the micro macro, where it's like, wow, I didn't realize like both linear algebra and this like kind of random probability facts can be really helpful in answering interesting questions about the world.
mm. So which professors of the faculty do you remember that made a big impression on you, while you were at Princeton, or that you were like maybe looked up to, or they had a big impression on you?
Yeah, so uh just a lot of them. So I definitely so the two people I ended up being the closest to by the time I was like graduating. So at Princeton you have to write what's called like a junior paper and
Hmm.
then senior thesis. And when you're doing that, you have like a advisor on the faculty who you're sort of supposed to like meet with every now and then to basically make sure you're actually writing something.
Hmm.
Uh, and so the advisor for my junior paper was this labor economist, Hank Farber.
Yeah. Yeah. I interviewed him on Friday.
Oh, amazing. So yeah, Hank, he was just, yeah, he was awesome. I went to go meet with it. Like I remember going to his office back when they were like the industrial relations section was in like the basement of the library.
Yeah.
Uh, and he was someone who was just like so enthusiastic about learning about the world.
Yeah.
Like I remember there was one time I was like going to visit his office, and I think it was like some new CPS month had dropped.
Uh-huh.
Like on his computer, just like calculating summary stats.
Right.
And
Right.
then like Orly Ashenfelter is down the hall, and Hank is like yelling statistics to Orly about, a month of the CPS. And that was just like, it was super inspirational to see someone like both of his stature and like so far along in his career still just like so enthusiastic about like learning from data and
Yeah.
caring about worlds.
Yeah.
Uh, so he was someone who's like uh, immensely like influential for me. And
Hmm.
the person who advised my senior thesis is this time series econometrician, Mark Watson.
Mm.
Uh, and I gotten to know him from like an econometrics class I'd taken. And
Mm.
he was he was like very early on, very just encouraging of what I was interested in. So I had somehow ended up taking like a class on machine learning. So I was like talking
Oh.
about, oh, this machine learning stuff sounds interesting. And he like very quickly is like, oh, that could be like really important. You should maybe think about is there something you could do with your senior thesis on it?
Mm.
Uh, and the fact that like again, someone of his stature and stage in his career was both like happy to talk to me and then also like very supportive was it's the sort of thing like it's amazing how much that sticks with you and how
Yeah.
like that
Yeah.
has on like, you yourself in like a broader community.
So what do you do your thesis on?
So I did my thesis on so I basically pulled a bunch of like macro time series from Fred, and then was asking how basically just trying to see how well could you do like 1 quarter ahead, 2 quarter ahead, 3 quarter ahead, like forecasts
Yep.
using various like sort of machine learning algorithms off the shelf.
Yeah.
And then always kind of trying to compare back to like simple AR models, simple
Hmm.
models, and
Hmm.
see like, what exactly is the sort of off the shelf power of the new prediction tools.
Yeah. So were you pretty excited by prediction in that by the time you were doing that thesis, or was that something that was kind of exciting you like for the first time?
Yeah, so I'd say it. I got interested in it during yeah, during like my junior year of college,
Mm,
where I had I took like some computer science class and like a class in optimization, but this was like 2015, 2016. And so there was these sort of um, big like breakthroughs on ImageNet, image
mm,
classification.
mm,
And so just people were people around Princeton in like the math and CS world were really excited about the potential of these algorithms.
mm,
And so that is what sparked it. And then I think Mark really encouraged me to like, oh, you should explore this a bit more.
mm, mm.
Who knows where this could go in economics?
Hmm. Hmm. So you're not just doing, I mean, you're saying that thesis is doing off the shelf things, but you're interacting a lot with these computer science and stats people,
Yeah.
and you're sort of knowing that there's a lot more there's a lot more than just the kind of stuff you're working on in this thesis that's
Yeah.
emerging right now. Ah,
Yeah. Yeah.
okay. Okay. So was it how quickly is it at Princeton that you realize I'm going to want to do a PhD in economics?
I think that's a good question. I think that probably, I think it entered into the option sets. Um, Maybe sometime, uh, in my junior year, I would say,
Mm,
where I think through interacting with Hank, I think he was very supportive of what I was working on in my junior
mm,
paper, and then suggesting like, you should think about if you enjoyed this, like you should think about doing a PhD.
mm-hmm.
Um, but I was still like a little unsure about, what is like this, what does the path of a PhD look like? So I
Yeah.
remember the like key decision point for me was all of my friends would do summer internships in various types of finance. So I was like, oh, maybe I should try this,
Yeah.
see what it's like to have a real job. Um, so did a summer internship working at a job in finance after my junior year.
Mm,
And it was really fun. But I both missed the like freedom to just sort of explore on your own. Um, and also I really suffered from having a boss tell me that I had to show up by
yeah.
like 8, be very
Right.
and if I left before
Right.
7 p.m.
Yeah.
And so it was Hank's encouragement trying that out that then when I came back in my senior year, I was like, well, might as well apply for a PhD, see what happens. And
Got
then,
it. Got it. Well, what was that first year like at Harvard? What was your expectations and what was it like?
yeah, it was, I guess my expectations going in were that it would be like not the first time, but, just like a chance to really do nothing else but sort of think about economics.
Yeah.
Like and do that surrounded by other people in my cohort who were doing exactly the same thing.
Mm-hmm.
Uh, and that was really the case. It was the first year was just, I really enjoyed it. I think what was nice was very clearly early on, sort of the department at Harvard, they made it very clear like classes are important, but don't, really stress out about getting grades. The point is not you're in competition with your friends. The point is you guys should be working together to like help each other learn.
Mm,
Um, and so I think that at least for me and for like my close circle of friends, I think that created like I was really fortunate that I was in an environment where, people weren't trying to compete with each other. Uh,
mm,
I was very supportive. And then I think I was also really lucky that I just got to meet faculty who were, you know, more than happy to waste time answering
Yeah.
my random questions. So quickly during the fall of my first year, Gary Chamberlain taught the sort of first semester of econometrics.
Yeah.
He was like just so generous with his time in his
Mm.
classes. And whenever I came to his office to ask him about, something related to class, he'd always want to know like what else were we interested in and what were we thinking about.
Mm.
Um, and that was again, it was just another example of like someone who's very senior being really generous and with a young person.
Hmm.
And that's really inspirational. And then I also got the chance to get to know Sendhil Mullainathan
Yeah.
pretty early this year. And he was somebody very similar, just really kind, really willing to spend time with someone who doesn't really know what they're doing.
Yeah.
And I think both of those plus my cohort and friends like made the first year like a really fun and exciting time of like classes, getting to start think about questions.
Yeah.
Yeah.
Yeah. So what's your first co-authored project while you're a PhD student? Do you remember?
Yeah. So I think the first one was um I guess it probably was this like papers and proceedings paper with Sendel,
Mm.
Dennis Ludwig, and John Kleinberg on algorithmic fairness. Uh,
Mm.
so I think that yeah, that must have been in like the late fall, early spring of my first year.
How'd that come
Uh,
about?
so that how did that come about? Um, So I remember, yeah, I think if I remember right, so I'd reached out to Sendel, sending him some email like, oh, I'm a first year student. I was really interested in machine learning as an undergrad. Now I'm in the economics department. It'd be great to talk. Um, and so he like said, yeah, we'll meet. Um, and what the thing he wanted to structure meetings around was like, what random thoughts have I had in the last,
Mm.
like if it's just something, it's just like a couple of sentences. Oh, I read this newspaper article. It's kind of interesting, stuff like that. And I think if I remember right, I was, I think it came out, this might have emerged from some conversation with Gary. Um, but I think it might have been Gary. I was talking to him about like statistical discrimination.
Mm.
Like sort of the model of statistical discrimination is people are forming predictions about some outcome, and those predictions are different across groups, and that's
Mm.
what leads to disparate treatment.
Right.
Uh, and so I remember, I think I sent Sendel an email like, oh, something like statistical discrimination seems related to like prediction, as we would talk about in machine learning.
Right. Right.
People statistically discriminate. Can like algorithms also statistically discriminate?
Oh yeah.
And then I think his response was like, oh, well, if you find that interesting, there's like, entire conferences and fields within computer science, like trying to think hard about this question.
Yeah.
Uh, like we should chat more about it. And
Mm.
so the papers and proceedings was they were talking about these ideas. And I kind of showed up at the right time to also think about it with them.
Hmm. Hmm. So fairness, algorithmic fairness, you can't really understand. It's a one way to understand it is to think about it in terms of statistical discrimination also happening with these algorithms.
Yeah. Yeah, I think that's right. I think, it's one way to think the way I think about it is, when we write down a sort of supervised learning
Oh yeah. Right.
algorithm, we write down some objective function and some data,
Yeah.
and we're effectively writing down a procedure to optimize that objective function given the data that we have.
Right.
All of our classic models in economics have that same structure.
Mm.
And so understanding when our algorithm behaves differently across groups, um, there are analogs of that, of course, in the literature exists a ton of work on discrimination. And I think
Mm.
a lot of work in algorithmic fairness, if you come at it from economics, can kind of be traced back to pointing out, this is a parallel of statistical discrimination as labor economists would talk about it. This is what it looks like when an algorithm does it. Um, but what's really interesting is that, the choices made by people are black boxes. You never really know what's going on inside a person's
Totally.
head.
Yeah. Right.
Write down and make precise what a supervised learning algorithm, what its objective function is, what data is it using, what
Yeah.
function class it's using. And perhaps we can then design them in ways to prevent that sort of disparate
It's
treatment.
very normative. It seems, I usually think of machine learning as very positive. It's like make a prediction, but you're bringing these normative questions into it by bringing up
Yeah, absolutely.
disparate treatment.
Yeah, absolutely. I mean, I think what's one thing that was really sort of striking to me early on in my PhD was how a lot of the questions that computer scientists were working on, you know, really had started to look like questions that economists had spent a long time thinking about, and we have a lot of, you know, skills and ideas to bring to the table. If you're
Mm.
as supervised learning algorithms now play a role in deciding who gets interviewed for a job, who gets
Right.
hired for a job,
Yep.
what defendants should be recommended for release or detention.
Mm.
Uh, those are canonically economic settings where we use economics to understand the data generating process.
Yeah.
All machine learning is summarizing features of that data generating process. So
Hmm.
we use ideas from economics to understand when these algorithms may work well, when they may perform poorly, and
Mm.
how might we fix that.
Hmm. I usually think, since I don't come from a machine learning background, I always just sort of, you know, imagine, well, in prediction, we're just trying to, minimize some weighted average of these false positives and false negatives. But I haven't really thought, it's like, I guess I had just sort of thought the machine learning algorithm was always going to be discriminating. Like it was always going to be taking groups and then imputing from the groups. But I must not really understand exactly what's at stake. Like, what ideally do you want? What's a fair algorithm doing?
Yeah, I think in a, in a sense, I think what you're asking is like the sort of foundational challenge in all of algorithmic, this work people call algorithmic fairness, algorithmic bias, which is, when we write down uh, a supervised learning problem, we specify an objective function, we specify what data we're going to use.
Yeah.
Talking about fairness is effectively talking about what's the choice of that objective function in the first place. You know,
Hmm.
we are we simply adopting some like utilitarian criterion where we're just going to try to minimize average loss in the population? You
Yeah.
know, want to make the fewest false positives, the fewest false negatives.
Hmm.
But the distribution of true positives and false positives and true negatives may be different across groups. So
Yeah.
therefore, minimizing the average, you may be doing things slightly differently across
Oh,
versus a minority group.
huh.
Is that what you really wanted to do in the first place?
Right.
And I think the reason this becomes so salient is, as prediction tools drift into really high stakes settings,
Mm.
sort of simple choices of that objective function really have enormous consequences. If you think in a hiring situation, a false negative is you did not hire someone who would have actually been a really productive worker.
Yep.
Um, and if that happens differently across racial groups, different
Mm.
genders, other protected characteristics,
Hmm.
um, this is enormously consequential. And
Mm.
the second bit is like, well, once you enter this game of trying to write down a formal definition of what it means to be fair or not,
Yeah.
there are many different ways you could try to write that down. I
Yeah.
mean, you know, the world of law has notions of disparate treatment, treating equal people differently in some sense, disparate impact. We don't want too large of differences in choices across groups. So even within law, you have, many different definitions that
Yeah.
could be operationalized. Uh,
Right.
and then once you start getting into all the different objective functions people write down in machine learning, you can incorporate fairness twists on all of them.
So these off the shelf machine learning models are potentially a problem
Yeah. Yeah,
for
yeah,
this
absolutely.
disparate treatment because they're not really fine tuned for a specific as well. A person might not even necessarily know. Well, I guess practitioners do know, but there might be some people that could not articulate what exactly the objective function might even be.
Yeah, and so I think if like the sort of core question that's animated a lot of work in fairness is how do we define what that means
Mm,
formally so that we can then try to optimize in some way.
yeah,
I think what that often surfaces is exactly the question you raise, which is oftentimes we don't agree on
right.
what does a fair hiring process look like? What does a fair college admissions process look like?
Mm,
Sort of what machine learning starts at is you've specified the problem. Now I know how to solve it in some sense, given some
yeah,
data.
yeah,
This is a question of how do you even specify the problem in the first place?
right, right. So are a lot of your peers, are they just as conversant in machine learning when you get there as you seem to be emerging? I mean, is it pretty much ubiquitous across your cohort that machine learning, or are you noticing that you're sort of moving into the edges of it a little bit more?
Yeah, I think when I started, it wasn't very common, certainly among in my cohort. And I think over time, I would say I've seen in the last, yeah, I guess I've now been 7 years ago is when I started my
Yeah,
PhD, which
right.
makes me feel older than I actually am. But I think it like since then, I think like each cohort coming in
Yeah.
comes in with like far more knowledge about it.
Hmm.
I remember like, starting in my third year, all people who were in the incoming cohort who maybe did an RA were like, oh yeah, I implemented XYZ, causal forest, lasso. Whereas when I started, um, I was in the yeah, I was sort of in the tail in the sense that I was thinking about these questions. Whereas I think by the time I was graduating, it became much more common.
Yeah. Well, but you also end up, okay, so who do you end up working primarily with Sendhil Mullainathan as your advisor?
Yeah, so he left Harvard at the end of my first year,
Oh, okay.
and I stayed in touch with him, but and wrote one more paper with him during my PhD. But that was we kind of I mean just by function of being in different places. So during my PhD, I'd say sort of the main people I spoke with the most were sort of Gary Chamberlain, but he unfortunately passed away during my third year.
Mm,
Uh, and I spent a lot of time talking to Neil Shepherd. So kind of from Mark Watson at Princeton, I'd always had this interest in time series
yeah.
and just sort of noticed in my first year that when time series people talk about causal effects, they use very different language than, the potential outcome framework that
Yep.
used to. And sort of Neil Shepherd was interested in similar questions at the time, so he became one of my main advisors. And then starting in I believe it was the end of my second year, beginning of my third year, Isaiah Andrews joined the faculty at Harvard,
Oh, is
and then
he's your main advisor?
yeah, so then sort of by the end of my PhD, I was mostly talking to Isaiah.
Ah, okay. So what do you end up having as your job market paper?
Yeah, so my job market paper was about actually very related to these motivated by a lot of these machine learning questions we're talking about. And for the starting point is across a wide variety high stakes settings, whether that's pretrial release, hiring, uh,
Mm.
medical diagnosis and treatment. Sort of a main policy tool people want to introduce is they want to, give a judge an algorithm in a sense.
Yeah.
Can we provide them with some sort of prediction in order to improve their decisions?
Right.
And a lot sort of hangs on improve their decisions, which implies they're making a mistake in some
Yeah.
sense. They're mispredicting some measure of risk based on the information that we could instead give to a supervised learning algorithm.
Hmm.
Uh, so in my job market paper, I try to think about that question a little more rigorously and ask, given the data we observe in these sorts of high stakes settings on uh, choices by decision makers, some measure of an outcome, and some characteristics of cases like defendants or job applications. Can we identify whether these decision makers are making prediction mistakes? They're
Yeah.
misforecasting risk based on information that we could have instead given to a machine learning algorithm.
Oh. So what's the setup? What's the, you have, I think I know the paper, but can
Yeah.
you, for the sake of the listener, what's the general institutional setup of the paper?
Yeah, so the sort of general setup is sort of we imagine that we have a decision maker, say a judge,
Yeah.
make choices whether to release or detain the defendant,
Hmm.
large number of defendants. And for each of those defendants, we get to see, a potentially really large set of characteristics, some
Hmm.
demographic information, their current charge, their prior arrest record.
Hmm.
Um, and if the judge decides to release this defendant, we also get to see whether they go on to commit some form of pretrial misconduct. So there's sort of this one-sided missing data selective labels problem.
Hmm.
And so uh, given that data we get to see, we would like to model the judge as they see the X's about defendants, they form some initial beliefs. Perhaps they additionally get to see some private information that we don't get to see because they, interact with defendants in the courtroom. And then based on the observed X's and their private information, they're going to form beliefs to maximize their own expected utility.
Mm.
So the question I ask in the paper is, does that model, if you place really no assumptions on private information, generate testable implications in their
Oh,
choices?
okay.
Uh, and it turns out under some assumptions, yeah, I think reasonable assumptions, the answer is yes.
Yeah.
And so then that's sort of the econometrics part of the paper is formalizing that identification question and result.
Mm.
Um, and then I take that data, take that result, and use it to analyze the pretrial system in New York and ask
Oh,
how many judges are making these prediction mistakes. If they are,
yeah.
what sort of cases are they making prediction mistakes on? And does our understanding of prediction mistakes help us understand when a pretrial release algorithm may be useful and
Oh,
helpful?
how bad is it?
So it's not great. Not great. So if you're like very conservative and favorable to the judge, it looks like at least 20% of all judges in New York make these prediction mistakes.
And what are they
They
predicting? They're predicting reoffending?
Yeah, they're pretty. So this is where there's, part of the gory details in this pretrial setting is, at least in New York, judges have a very well-defined legal objective, what they're supposed to care about.
Yeah.
They're really supposed to base this decision on whether someone would fail to appear in court on their date or not.
Yeah.
Um,
Oh,
so
okay. Showing up at court.
will they actually show
Right. It's
up?
this is pretrial detention. Got it.
Um, and then you can do robustness checks to say, well, suppose the judge cares about both failure to appear risk, but also being rearrested,
Hmm.
or failure to appear risk and being rearrested for a violent crime.
Hmm.
So you can basically rerun the identification analysis for sort of richer definitions of the outcome they care about and are
Yep.
predicting.
Hmm.
Um, but sort of under the most conservative set of assumptions, meaning most favorable to the judges, it looks like at least 20% of judges in New York do make these mistakes. It's quite a large number.
Yep.
They happen on like I think it's like 30 to 40% of all defendants
And
of a
it
state.
varies by group. It sounds like it's going to be unfair too, right?
Yeah, and it varies across groups. So
Yeah.
you tend to see more prediction mistakes on minority defendants as well.
Right, right. So with your algorithmic approach, how do you know if it's a mistake? You don't observe the counterfactual for any of these guys. So how do you know when you predict that they would have shown up had that judge not, taken an action against them? It seems like it's just such a messy, complex problem that you're sort of stuck in to try to even see if there's any errors, right? Am I thinking of it right?
Yeah, no, that's exactly right. Sort of a slightly different way to say the problem you're pointing out is we again have, the fundamental problem of causal inference. We don't know what would have happened in the counterfactual.
Mm-hmm.
We don't get to see whether a detained defendant would have actually failed to appear in court.
Yeah.
And so part of the work in the paper is to show sort of first that if we have any sort of instrument that affects the decision but is unrelated to risk,
Yeah.
which in a lot of these settings happens from the sort of quasi-random assignment of decision makers to cases, um, even without resorting to assumptions like monotonicity, you can bound what is risk among the detained in this example. So you can sort of bound
Mm-hmm.
what that counterfactual can look like. And then it turns out that bound is sufficient to test for prediction mistakes.
Mm-hmm.
Ask, can you find a release defendant who is more risky than the best case counterfactual for a detained defendant?
Mm-hmm.
And if that's true, this judge should be able to swap their choices on this pair of defendants and do strictly better, assuming that they're actually trying to maximize or they're actually caring about failure to appear risk in this example.
Have you guys ever tried to present this to outside of academia to people like this? And if so, what's your sense of the obstacles out in the real world to this kind? I mean, in criminal justice, they're so open to the algorithms and have been for decades.
Yeah. Yeah. So I think it's a great question. So I think I would identify at least two big challenges that I see. So one is, on the one hand, sort of this evidence suggests that a lot of judges make sizable mistakes. They really matter.
Mm-hmm.
But one thing that's often very surprising, it's true in this pretrial setting, and it's often true in many high stakes settings as well, is that decision makers actually get very little feedback about their choices. Basically, if a judge releases a defendant, they never actually know that that person failed to
Yeah,
appear in court unless they're rearrested and they show up back in their court.
totally. Is that just because of the decentralized nature of the criminal? It's like, one hand doesn't really talk to the other.
Yeah, exactly.
Yeah, yeah,
And
yeah.
so, in a sense, if I show up on the bench and I never get feedback, how am I supposed to learn over
Yep.
time I'm making the
Yeah,
wrong choice?
totally, totally.
And so there's this sort
That
of
might reinforce some of the judge fixed effects principles, which is just kind of I'm just going to keep doing what I've been doing,
exactly,
which might lead to some sort of habit or bias or whatever. Yeah, yeah, yeah.
exactly.
Right.
And so there's an institutional question. Why doesn't that feedback exist? And how might we design it
Yeah.
uh, if we could? And then the second is, I think, where I started is, the response to this work has been, well, we should incorporate algorithms into decision making.
Yeah.
Uh, but oftentimes the way this gets introduced is we're just going to give a judge a recommendation, maybe some risk score, and then they'll have to look at the recommendation and risk score and then make their own decision. Or we're going to give a doctor a risk score and a recommendation or a guideline, and then they'll still have to make the decision themselves.
Yeah.
Uh, and sort of the hope, I think the reasonable hope is, well, if judges see some extra information that's not available to the risk score,
Yeah.
ideally, if they're rational, they would combine these two information sources
Mm-hmm.
and make a better decision.
Mm-hmm.
But I think what we've often seen in practice is the effects of giving people algorithms are either there is no effect, people don't really pay attention to them,
Oh.
or they lead to sort of surprising changes in behavior. So someone who I overlapped with briefly at Harvard, Alex Albright, has some like really wonderful work showing that basically when Kentucky rolled out a risk score and recommendation tool, it had some sort of surprising effects on disparities in pretrial release decisions between Black and
Mm,
whites.
mm,
And so it's a long way of saying I think now like what excites me econometrically is this sort of screams out that, we started from let's test if decision makers are rational, they have correct beliefs, they don't. So
mhm,
they're clearly behavioral, they're making mistakes in some way. But we're presenting, them with supervised learning algorithms that are just statistical objects that are not designed with them in mind.
mm.
So how do we design algorithms in response to behavioral biases and mistakes that we can identify in data? I think that's really wide open, fertile ground. And what excites me about it is, I think coming back to, we're talking about why I ended up in economics. It's like
Yeah.
a clear route to how we can have impact in the world
I was
as,
just thinking, it's just that it's kind of, you really haven't left that core interest that you had in policy questions.
yeah,
From a distance, people don't really associate that with machine learning. They do associate that with causal inference. But,
yeah.
it's funny that until now, I hadn't really seen that connection, that your driving interest has continued to be about public policy, sort of.
Yeah, yeah, absolutely. I mean, I think, um, yeah, now that I get to be, an assistant professor, I get to stand on my soapbox every now and
Yeah,
then
sure,
with
sure.
students. And I think I guess I firmly believe, we are in the field of economics, we do econometrics because we care about the intersection of statistics and economics.
Yeah,
I think what makes economics amazing is it's like it is a social science that cares about impact in the world. We can argue
right,
about whether it's positive impact or negative impact,
right.
but we as a field value people who make contributions to how we as a society think about important policy
Yeah,
questions.
yeah,
Econometrics is beautiful because we can provide the tools to help people answer those questions, whether that's
yeah,
in causal inference, whether that's building new machinery in the world of machine learning.
yeah.
Um, we can therefore play like a huge role in.
Right. Right. Well, I want to talk about one more paper, and then I feel like I'm obligated to let you get back to your job. But this paper that you wrote with John Roth on parallel trends, credible approach to parallel trends, I was wondering if you could, just for the sake of the listener, sort of say, what is that paper about, and why is that paper kind of what is the value of that paper, for practitioners that do difference and differences?
Yeah. So I think so what we're trying to do in that paper is when researchers we care about important policy changes, but we can't randomize everything.
Right.
And so we often resort because there's just no better option when we have staggered variation. We have some states adopt a policy, but some don't. How can we measure the causal effect of that policy? And so then the standard way we analyze that data is through a difference in differences or an event study design.
Yep.
Uh, but that design rests on the parallel trends assumption. In the simplest form, the sort of control potential outcomes would have evolved similarly in treated and control states. Uh, and if we believe that assumption, we can learn the average treatment effect on the treated. Everything is great. But I think if you inject truth serum into anyone, no one really believes that that thing holds exactly.
Right.
And so what we try to do in this paper is to give applied researchers a framework for
Yeah.
thinking about how they can measure the robustness of their difference in differences or event study design
Yep.
to of the parallel trends assumption,
Hmm.
explore how sensitive would our policy conclusions be if that assumption were violated.
Yeah.
Uh, So hopefully what the paper does is it allows researchers to sort of more clearly explore the mapping between, intuitive violations of parallel trends that we often talk about in seminars
Hmm.
to the formal statements that we make.
And the intuitive violations are coming off of the event study, right? They're coming off of the
Exactly,
pre-trends.
exactly,
Yeah.
exactly.
Yeah.
We see variation in the pre-trends. Perhaps things look like they're trending in a particular direction over time. We
Hmm.
see large differences between treated and control units in the pre-trends.
Hmm.
And then when we look at those event study plots, we're forming, I think, subjective judgments on what would
Yeah.
likely happen post period.
Yeah.
And so what we do in the paper is try to write down an econometric framework to formalize those sorts of subjective, hand extrapolations that we're doing in our
Right.
head.
Right. Right. So let's say there's somebody out there writing a paper, they have their event study and they're like, I really wish I could show this to Ashesh. What is it you're going to be looking at in that event study that might make you go, I think you're fine? And then another thing you're going to be looking at, you're going to say, I think maybe this new paper about me and John Roth would be worth doing. Like, what exactly are the pieces of information that you're wanting them to be paying attention to?
Yeah, that's a great question. So I think like a good, and honestly, it's how the paper it's how the paper started with me and John was just, taking the event study plot and sort of one benchmark case we think about is suppose there were like a linear violation of parallel trends or some
Mhm.
relaxation of linear violations of parallel trends.
Yeah.
And so I remember early on in the paper, John and I, we would look at event studies and try to just like stick our
Sure.
pen in the confidence interval and see like what sort of lines could you draw
Yep.
through. And I think if you do that on an event study and you see like you could draw many different lines through the pre-period confidence intervals, I think you should then want to think very carefully about what what is the content of the parallel trends assumption?
Yep.
Should we be working on violations? And then, use our methods to try to think about reporting robust confidence intervals. And I think in a similar sense, if you see in your pre-periods, everything looks good, but there's, maybe perhaps one period or two periods where there is a large difference, but
Yep.
on average, things look close to zero in the pre-period. That might be another suggestion that there are some time varying shock that leads to differences between treated and control units, a different set of relaxations we consider sort of formalize that idea.
You think you would literally recommend to somebody get out a ruler and draw a straight line through the confidence intervals and if you can do that and it not be on the post treatment like a parallel trend, use my method to bound it.
I think so. My formal recommendation would be to start with our methods, set the parameter m as zero, and then start relax.
Oh, yeah.
But I think oftentimes that's like it's a pretty good like just rule of thumb check.
Hmm. Hmm.
Just have
M of zero being the code.
yeah,
Set the M of zero meaning no parallel trends violation, and then just gradually increase it.
yeah. So and I guess in depending on the choice of there are these like sets, capital delta. So for the one that is associated with relaxations of linear trends, M is zero is allowing for a linear trend
Yeah.
or any sort of worst case linear extrapolation.
Yeah.
So I start there. That's sort of formalizing the intuitive line checking.
Hmm.
And
Hmm.
then as you allow M to be larger, you're allowing for more nonlinear extrapolations.
Oh, okay. Cool. Cool. Well, let me end with this. So, this is not asking you to be like, well, I've done a year as a as a professor, so I know everything. I'm not asking it like that. I'm saying more like if you could imagine being in a room with a bunch of new assistant professors all over the country, right? they're starting out this year. What would you say like the most valuable thing it is that you've learned this last year with, 1 year under your belt, like about your own, how you're going to try to drive this train to tenure? It's like, what is it that you think you learned in this last year that, you know, you would say to a bunch of people, whether it's right or whether it's wrong?
That's a great question. I mean, I guess I don't know if it drives the train to tenure, but I was actually having dinner with one of my friends here last night, and we were just talking about it's one thing that is amazing about being an academic is how little structured feedback you
Yep.
get.
Mm,
And more often than not, that structured feedback is negative.
yeah.
Most of the time you submit a paper, it's going to get rejected.
Right.
When you give a seminar, people are far more likely to ask you a hard question than give you a compliment. And I found it we were talking about how it's very easy to just get, really down in the dumps if the only thing you're hearing is negative feedback. And sort of an internal goal I've had for myself is to, when someone's giving a seminar and I really enjoy it, actually tell that person, really
Right.
enjoy the paper. I found the paper insightful. Starting, in referee reports, if I liked a part of the paper, actually saying I like this part of the paper.
Hmm.
Like I found that when people have done that for me, it really sticks with me.
Yep.
And if I would like the profession to be more like that, I can control my own behavior. Um,
Hmm.
and so I think as a community, like, I think a lot of economics is really wonderful and very friendly. And I think we can like continue doing that for each other and really trying to send positive vibes out into the world. And hopefully that
Yeah.
makes us more happy and productive.
Well, I wonder if you drew a lucky card with that cohort at Harvard that was super friendly
Yeah.
and
Yeah.
collaborative,
I think it did. I think whenever I hear the horror stories, I mean, I think I was really lucky that,
because you probably were getting that a little bit more often,
yeah,
right? I mean, you were
yeah,
probably hearing it from one another, and you said it wasn't as, I mean, maybe some, I'm not positive, but maybe some of that negativity is, it definitely isn't helped by the competitive environment,
yeah.
you
Yeah, yeah,
know?
absolutely.
Right.
Absolutely. I think I've been really lucky to really enjoy my time as an economist. Who knows how long it will last, but
Yeah.
I think like that shouldn't be the exception, I think.
Right.
And we have a lot of control, and especially now that you're an assistant professor, like it's a very big change that you're now actually an authority figure for
Mm,
so many young people.
yep.
And we'll be looking at you, how you behave in seminars, how you behave in the classroom, how you behave in meetings.
Yep.
And you can't be complaining about unfriendliness in the profession if you yourself are also unfriendly to like the people around you.
Totally. 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 That's a great way to, that's a great thing. Well, good luck on all this very cool work. I mean, it's, you know, the predictive algorithmic work, but that's super, in some ways, I mean, I'm just kind of rambling here for a second, but in some ways, we think of causal inference as like the most directly policy relevant, but that's a bit of a fantasy in a way because you're kind of hoping somebody's going to read your minimum wage paper and then like a legislator's going to do something,
Mhm.
which, but the algorithmic work like gets brought in to agencies and is then used.
Yeah.
So it is kind of wild that, I mean, you're doing both. You're directly in the full machinery of influencing policy by doing so much fundamental work on causal inference and in this predictive algorithm. But it is kind of interesting to think that the creating of these algorithms actually might have direct, immediate consequences for people's lives, which is what you were saying had always been sort of your something that really drove you.
Yeah, yeah, absolutely. I mean, I think, yeah, one short story is I did some work when I was a PhD student and still talking with them about at this large investment bank in Australia. And
Yeah.
it was just talking with them about work on academic work on algorithmic fairness, how we can improve supervised learning. And it's the sort of thing where there was no causal question. All they were
Right.
interested in, how do we predict
Yeah.
which applications they should fund or not.
Yeah.
But clearly, small changes in what that algorithm looks like, if they're processing hundreds of thousands of applications a year, small changes in a percentage sense are huge absolute changes in the allocation of credit. If you think about this in labor markets, who gets a job? If you're thinking about in this criminal justice system, who gets jailed versus released.
Yep.
So the scope for impact, I think, is really large. And as I say, I think that's what makes economics amazing. We're a field driven by impact in the world, and
Yeah.
we tools available to think about it.
Yeah. It's awesome. Well, it's very cool to have you in the profession. It's really nice today to meet, and I hope we get to talk again
Yeah,
uh,
absolutely.
in real life or something.
Yeah, absolutely. This was really fun, Scott.
Okay. All right. I'll see you later, man.
See ya.